All right, so in your packet you have part 1 and part 2. I expect that we get through part 1 today. I doubt that we hit all of part 2 today, okay? But in the event that we do, I went ahead and took pictures of both of them, so we can keep going if we have time. We'll see. So no phones. Let's just go ahead and put those away. Oh, like up, like February's coming. I'm excited. I'm going on vacation at the end of the year.
Where are you going?
I don't know, but I'm fundraising by taking up phones. It's going to be great. Okay, so it says, in this course, we are going to approach angles in a way that may be different than what you've seen in the past. We will approach angles in a generalized method that allows us to view them from a periodic lens. What? Okay, so to do this, we must first make a few definitions. Definition 1, standard position of an angle. In the coordinate plane, an angle is in its standard position when its vertex, so that's kind of the elbow joint of the angle, when the vertex is located at the origin and one ray of the angle lies on the positive x-axis. That's standard position of an angle. Okay, so we're not going to see an angle that opens up with any more than just one on the positive x-axis. So for you guys, that's over here. And then the other side will open from there. So kind of Lion King horizon-ish. Are you with me? The terminal ray is the second ray of the angle in standard position. So if you have your first ray, then the terminal ray is, where does it end? Terminal meaning the ending. Cool? Okay. Did you say
That's an
Use okay. So the figure above shows an angle in standard position. Okay. Now, given an angle in standard position, Joseph's first question today is, are we going to use SOHCAHTOA? Was that you or you? Truett? Okay, sorry. Shots fired. SOHCAHTOA. So what you're saying there is that sine is equal to opposite over hypotenuse, right? That holds true here. But if I'm looking at this little circle down here in the bottom of your paper, the opposite side of the angle is going to be y. It's going to be my y value. Everybody seeing that? So the ratio is going to be y, the vertical displacement. So above vertical displacement, you might write y. From the x-axis to the distance between the origin and point P. Point P being anywhere. Any distance from the origin to a point on the circle is called the what? Radius. So sine of theta is going to be found by using the ratio y over r. Opposite over a hypotenuse. Hey, this seems like we've done this before. Cosine of theta, ca, is going to be adjacent over hypotenuse. Or, in this case, the horizontal displacement, also known as x, divided by the distance from the origin to P, which we called the radius. So cosine theta is x over r. X over r. Okay. And then tangent, you said SOHCAHTOA. So tangent theta is opposite over adjacent. Opposite over adjacent. So in this case, tangent theta is the slope. Guys, you need to know that. Tangent's the slope. It's the rise over the run. It's the ratio of y to x. Vertical displacement to horizontal displacement. Tangent theta is also the identity sine theta over cosine theta. Why? Because sine is y. Cosine tells me the x values. Okay, sine theta over cosine theta. Is this all ringing a bell to you? We're feeling pretty good about this? Okay, so let's go on. Okay, so we've got a beautiful little example one, a circle up here. It says the figure shows a circle centered at origin P with an angle of measure theta. That is T-H-E-T-A. Okay, let's be educated about this. Theta. It's Greek. Okay, don't come at me with this word. That's cheese. Okay, I hear that a lot. Theta, theta, theta. That's crumbly cheese. That is not this. Okay. I'll leave it alone. It's a pet peeve. Yeah. All right, so the figure shows a circle centered at the origin with an angle measure theta in standard position. The terminal ray of the angle intersects the circle at point P. The coordinates of P are x, comma, y. So the coordinates of P are x, comma, y. Which of the following is true about the cosine of theta? Well, cosine theta is known to be the x value divided by the radius. What is the x value at point P? No? We don't know. It's just x, yeah? At point P, the x value is x. But what is r? What is the radius of said circle? There's your 3. And you only know that by looking here. They gave you this distance out to the edge of the circle. They tell you it's located at 3, 0. Well, if the distance from the origin to that point is 3, then the distance from the origin to point P is also 3. So cosine of theta is going to equal x divided by 3. So A. Because it is the ratio of horizontal displacement of P from the y-axis to the distance between the origin and P. What do you think? Why is it not B?
Because y would be
Sine theta. Good. Why is it not C? That would be tangent. Why is it not D?
because the x is on the wrong side.
Oh, because it's flip-flopped. Anybody know the name of that function? That's the reciprocal of cosine.
Cosine prime. No.
He said cosine prime. That was a good try. Not cosine inverse. Not inverse. It's reciprocal. It's not an inverse function. We learned 3 of them. Oh! Now you're on the right track.
Cotangent, cosine. No, it's cotangent.
Cosecant. No, it's not cosecant. It's secant. No cos go together. It's secant. Secant. Secant's the reciprocal of cosine. Good. So this would be secant theta. It would be the 3 over x. It would be the reciprocal. Man, you're thinking. Good job. All right, example 2 then. Example 2, it says the figure shows a circle with radius 5. So circle with radius 5. That means to the point P, this R business is 5. Centered at the origin with an angle of measure theta in standard position. The terminal ray of the angle intersects the circle at point P. Okay, so we've gone standard position. It's gone all the way around to here. Are y'all seeing that?
Yes.
Okay. At point P, find the following values. And also note that P seems to be a reflection of this point, 3, 4. Seems to be a reflection across the x-axis. So what do you think? 3, what? So point P could be located at 3, -4. I like that. So sine of measure theta
Be y over.
y over r. Good. Y divided by r. Y being -4, r being 5. This is a 3, 4, 5 triangle. It's a 3, 4, 5 triangle located in quadrant 4.
So this one,
Cosine theta is going to be
3 over 5.
3 over 5. Good. X over r.
And this one,
And then
is it X over Y, Y over X.
Opposite over adjacent. Y over X. Rise over run.
Yeah,
4 over 3. Positive or negative? Negative 4/3. Okay, so here's the workaround on that, and I want to just write it out for you. It's always sine over cosine. Tangent is always sine over cosine. If sine is negative 4/5 and I divide by cosine 3/5, then I'm dealing with negative 4/5 times the reciprocal of 3/5, which is 5/3. Negative 4/3.
Whoa. There's 3 little.
Okay? That's how I do it. I always find my sine and divide by cosine. And then I know I'm going to multiply by the reciprocal of of cosine. And I get my tangent. Y over X. Rise over run. Rise over run. Okay, let's go on. So on the next page, you've got this circle with radius r centered about the origin. The terminal ray of the angle intersects the circle at P. The coordinates of P are x, comma, y. The points Q, R, and S are the result of reflecting point P across the y-axis, across the origin, and across the x-axis. Can you see how they're coming up with Q, R, and S? Okay. So find the coordinates of the points Q, R, and S in terms of x and y. So let's start with Q over here. Good. Negative x, positive y. I like. How about for R? Negative x, negative y. Nice. And for S? X, negative y. Good. So that's going to be helpful as we move around these values in the circle, understanding what's happening with x and y. So number 4, example 4 says, find the sine of the angle whose terminal ray intersects at point S. Find the sine of the angle whose terminal point intersects at point S. And the radius is r. Negative y over r. Good. So we're looking at point S, whose value, ordered pair, is x comma negative y. Sine is y over r. So in this case, the y value is negative y. And the radius is r. Is that making sense? Ross, you good? Let's try example 5. Find the cosine of the angle whose terminal ray intersects the circle at point Q. So kind of find point Q over here. What is the ordered pair at point Q? Negative x, positive y, right? Cosine is the ratio of x over r. So at point Q, what's my x value?
Negative.
And r is still r. Is that better? Okay. Questions, anybody? Example 6. Find the tangent of the angle whose terminal ray intersects the circle at point R. Okay, so he says at R, negative y over negative x. I agree. Simplify. Y over x. So in quadrant 3, tangent's positive again. Tangent's always positive in 1 and 3. 1 and 3, because it's a ratio of y over x. So a positive divided by a positive is positive. And in quadrant 3, what am I dealing with? A negative divided by a negative, which is also positive. Questions on that? Are we remembering? Is it coming back to you? Are y'all asleep? All of my classes have been asleep today. Oh. All right, let theta be an angle in standard position whose terminal ray coincides with the line y equals negative 3x in quadrant 2. Okay, so let's get to graphing this guy. Wow, let's graph it better than that. Okay. Graphing y equals negative 3x. So where does that line begin if I'm just going to start at B, at the origin? And then from that value, 0, what can I do? Down 3, right 1, or what else could I have done? Up 3, left 1. Good. And I'm only interested in this line whose terminal ray coincides with the line in quadrant 2. So I'm actually interested in this ray. Only the part of this line that's in quadrant 2. Everybody okay with that? Okay. Find the following values. So sine of theta, first of all, what's this point right here? What's the value of this point where we went up 3 and left 1? Where's that? Okay, I like that point. I think that point would be very helpful to know. And my next question for you is, what's the distance r from the origin to that point? How could we find that? The Pythagorean theorem, right? A little bit of a squared plus b squared equals c squared, where my triangle has lengths 1 and 3. So r is going to be the square root of 10. Okay, that's helpful. So if I was drawing a circle that kind of fit all of this information into it, I'm talking about the point P, negative 1, 3, and the radius, square root 10. You seeing how we came up with all of this information? So now, what's sine of theta? 3 over square root 10. It's not so bad. Cosine theta. I like it. Negative 1 over square root 10. And tangent theta? Negative 3. Guess what? It's the slope of the line. Whoa! Did you see it? Did you see how that worked out? Rise over run. Questions at all? No? Are we able to keep going? Are you alive enough to keep going? Are we able to keep going? You have it in you? Yes, you're gone tomorrow, aren't you? No? Okay. So let's see, where did we leave off? All right, part 2. In the coordinate plane, an angle is in standard position when its vertex is at the origin and one ray lines on the positive axis, the terminal ray is on the other, wherever it goes, right? Positive and negative angle measures simply indicate the direction of the rotation from the positive axis. So if you're dealing with a positive angle, that means we went in the counterclockwise direction. Guys, this is hugely important. Counterclockwise. How does that read?
That way.
You need to write that down. Positive angles are measured counterclockwise. This is a torque thing in physics. Torque. Negative angles are measured in the clockwise direction. This is huge. Really, really important. So the figure above indicates a positive angle because the direction of its rotation, they started at the x-axis and they went counterclockwise. So you know it's a positive. Good? Questions at all? Okay. The way we will measure angles throughout this course and in future courses may seem strange at first. The way that we're coming up with these numbers is theta is equal to the ratio of arc length per radius. Theta, the measure of the angle, is the ratio of the arc length of the circle divided by the circle's radius. Okay? One thing that you need to remember is circumference of a circle is 2 pi times its radius. Circumference. So how far around the circle? 2 pi being the period. How long does it take me to make one revolution? 2 pi radians. Times r, the circle's radius. So the bigger the circle, the more distance it covers. You with me? So arc length is 2 pi times the radius. Okay. Let's go on to the next page and see if we can apply this a little bit better. Y'all said we were okay with this, and then all of a sudden y'all went to sleep. Are we going to what?
Use like that pie chart, you know, the circle one.
A lot. Mm-hmm.
I hated that chart.
Unit circle. Uh-huh.
No.
It depends on what the argument is, but it's okay. What's the formula for circumference again?
2 pi r. 2 pi times the radius. Okay, so arc length divided by radius gives me theta. It says, consider the angle theta created by the quarter circle of radius 4 above. Find the measure of theta. Okay, so it's a quarter circle. So I'm going to do... I don't know. Just now? Okay. So it says, consider the angle theta created by the quarter circle. So for my arc length, I'm going to have 2 pi r, but I'm only using a quarter of that because it's only going a quarter of the way around the circle. Yeah?
Yeah.
Divided by radius, which is 4. I'm looking for theta. Theta is arc length divided by radius. Arc length is 2 pi r. It's the distance around. It's circumference.
Your radius is 4.
This time my radius is 4. 1/4 of 2 pi times 4. Watch, the 4s are going to cancel.
That's a 4. That's a 2.
All over 4. That is a 4. That is a 2. Okay, so my quarter and the 4 on the end, the r, cancel. And I'm left with 2 pi divided by 4. Can we simplify that? Pi over radius. So I've got arc length, which is 2 pi times the radius, all divided by the radius. My radius is going to cancel. This one.
Your radius is 4 if you look at the graph.
Oh.
Right. Pi over 2 is going to be theta. Notice that it landed at the top. That's what we call pi over 2. Yeah. Find the measure of the angle formed by 1/3 of a circle with radius 3. So theta is going to equal 1/3 of a pi r, or of a 2 pi r. And this time, what's the radius? All over the radius, which is, see, the 1/3 and the 3 are going to cancel here. What's it called? 2 pi over 3. That's 1/3 of a way around. Getting better? Do we want to stop for today? Are y'all fried? What's wrong? We've got 20 minutes left. We got 20 minutes. Can y'all hang in there? I mean, honestly, can we wake up? Do we need to sing head and shoulders, knees and toes? We can. I can make you stand up. Okay. Truett can't touch his toes. It could be fun to watch. Should we try?
Yeah. I want to see that.
In a minute. Okay, so the unit circle. This is where we're headed. The unit circle. Unit circle is a circle centered at the origin. What is special about the unit circle is that it has a radius of 1 unit. The unit circle. Okay? So for the unit circle, the radian measure is the same as the arc length because every time I'm dividing by 1. The concept of the unit circle will become pivotal throughout the rest of this course because of its incredible usefulness when working with trig values. Y'all, I mean, it's pivotal because of its incredible usefulness. Get excited. Turn the page. Y'all, we can do this. I'm encouraged. I'm feeling a burst of energy. Okay. Okay, so it says for each of the following, sketch a picture of the arc length described based on a unit circle. So good news, R is 1. R is 1. Okay. Find the measure of the angle corresponding to the given arc length. So we're going to draw a picture. So we want 1/6 of a circle in the counterclockwise direction. So we're going to start at the x-axis, and we're drawing a 1/6 of this circle. So not 2/3 of the way.
Half of the half.
Really, a 1/6 of the way.
That's like 5/6. What in the world? Oh.
Start on the x-axis, always. In standard position, we always start on the x-axis. If it says counterclockwise, then we're going up. A 1/6 of the way around the circle. So what I just did there in my little brain is I took this circle and I split it into 1/6. 1, 2, 3, 4, 5, 6.
Quote unquote little brain.
Y'all see?
Yeah.
Something like that?
Little brain. You got a big old brain.
Okay. So what's theta? Theta is going to be 1/6 times 2 pi times r, which is 1, divided by r, which is 1. So a 1/6 of 2 pi simplifies to be pi over 3. So at this angle, where I'm a 1/6 of the way around the circle, theta is pi over 3.
Well, because you multiply times.
Divided. 2 divided by 6 is 1/3.
But you multiply times 2.
Yeah, 1/6 times 2. Yeah. Okay. I'm having major regrets today. Like, why did I come to school? 2 full revolutions in the clockwise direction. 2 full revolutions in the clockwise.
Right and tiny.
Yes.
It's a symbol.
That's all you
No. -0. We have to show like
Not negative. So by the time I've gone 2 full revolutions, I've gone 2 times 2 pi. 4 pi. But I went backwards.
-2.
So theta equals -4 pi. Good.
On our drawings, we have to
It's
show
like a
like
swirl.
the reverse of that.
Woo. He said righty-tighty. Lefty-loosey. You're not wrong. That's the torque that I was telling you about. I teach that in my physics class. All right. Letter C. 3/4 of a circle in the counterclockwise direction. 3/4 of a circle in the counterclockwise direction. Can we do it? We're going to start in standard position. Watch this. 1/4, 2/4,
Oh no.
3/4.
Whoa.
So theta is going to be 3/4 times 2 pi times r, which is 1, divided by r, which is 1, right? What's 3/4 of 2 pi? Okay, so the 4 and the 2 can reduce down. 3 pi over 2. Guess what? That's what we call the negative y-axis, 3 pi over 2 in the unit circle. Okay. Letter D, 7/8 of a circle in the counterclockwise direction. 7/8 in the counterclockwise direction. So we're going, watch this, 2/8, 4/8, halfway, 6/8, 3/4 of the way, 7/8. So theta is equal to 7/8 times 7/8 of 2 pi.
7/4.
Oh, 7 pi over 4. Counterclockwise, so it's positive.
And we're done.
No, we've got this whole beautiful unit circle down here. Check it out. What is... We're doing it. This is a unit circle.
You're doing it.
Okay, so listen.
Trauma in this circle.
Listen. We're going to fill it out. We're going to talk through it. Starting at 0. If I go one full trip around the circle, how many radians have I completed?
360.
360 degrees. 2 pi radians, right? It's 2 pi all the way around. Oh. Which makes halfway around
1 pi.
1 pi. Watch. Pi. Okay, so far so good, right? If I only go halfway to pi, pi over 2. Okay? Yes! Now, 1 pi over 2.
2 pi over 2.
2 pi over 2, also known as pi,
3 pi over 2.
makes this bottom one 3 pi over 2. So far, so good? Yeah. Okay, so now let's back up and think about this in terms of fourths. Okay, if I go 1/4 of the way to pi, that's this guy, pi over 4. Okay, that's 1/4. Look, I'm going to shade it in. That's 1/4 of the pi. Now let's go 2/4 of the pi. Where am I located? Half. 2/4 is half. Okay, go over another quarter. This guy's 3/4. 3 pi over 4. Do another quarter. 4 pi over 4, also known as pi. Let's go another quarter. Nope. 4 pi over 4 plus 1 more. 5 pi over 4. And then, look, 6 pi over 4. How does that reduce?
3 pi over 2.
3 pi over 2.
Yay.
And then go another one. 7 pi over 4. And then another one. 8 pi over 4, also known as 2 pi. See, y'all, you're just brilliant. And I love y'all. Let's change colors here. Let's do thirds. Let's do thirds. Okay? Pretend like I'm going to slice this pie into thirds. This pie being only the top half. Cut the top half into thirds. This first third is called pi over 3, right? Slide over another third, and what do we have?
2 pi over 3.
2 pi over 3. Slide down another third, and what do we have?
3 pi over
3 pi over 3, also known as pi. That's where you check yourself. Okay? Go another third. What do you got? 4 pi over 3. Go another third. What do you have? 4 pi over 3 plus 1 more pi over 3. 5 pi over 3. Poor y'all. Plus another one. 6 pi over 3. Reduce it. 2 pi. 2 pi. 2. Gosh. Regards. I'm gonna quit. I'm gonna work at Hobby Lobby. It smells good. They play good music. Okay, here we go again. Last trip around this beautiful little unit circle. We're gonna split pi, splitting the top half into sixths. So little bitty slivers here. What you got first? Pi over 6. Get another one. What do you got? 2 pi over 6, also known as pi over 3. Do another one. 3 pi over 6. Looky there, a half. Go again. 4 pi over 6. Uh-oh. This guy should be 4 pi over 6, also known as 2 pi over 3. Same thing, right? Okay, go again. 4 pi over 6, so that makes this next one 5 pi over 6. 5 pi over 6. Go again. 6 pi over 6, also known as pi. Okay, next. 7 pi over 6. And then 8 pi over 6. Check yourself. Is that 4 pi over 3? 8 pi over 6? Yeah. And then again. 9 pi over 6. 3 pi over 2. 10 pi over 6. 5 pi over 3. What's this one? 11 pi over 6. What's the next one? 12 pi over 6, also known as 2 pi. Okay. You got the angles written in? Do you?
1 minute.
Okay. So operating on this unit circle, guys, we got 6 minutes. We're going to knock this out. Turn the page and get it going. So for a unit circle, the radius is 1. As a result, the sine and cosine values of an angle in standard position are simplified. Okay, radius is 1. So look at example 5 down here. This shows us an angle cut to theta where P is located at 1/2 comma square root 3 over 2. They don't tell you what angle this is. What is sine of that angle? The y value, because this is a unit circle. So the y value is square root 3 over 2. Okay, are we skipping anything here? Do you understand that when the unit circle radius is 1, so instead of sine being y over r, it's just y? Because r is 1. So on the unit circle, the sine of the y value is just the y value. Sine of theta is just the y. What's cosine theta at this point? 1/2. And tangent theta is going to be sine over cosine. Square root 3 over 2 over 1/2, which means I'm multiplying by the reciprocal, which means I'm left with, feeling better? Yeah. Tangent theta is 1 square root 3. Okay. Last one. They say let R be reflected over the y-axis. So now R is going to be reflected over the y-axis. That's over here. So negative 1/2. Did y go negative? Okay. So sine of alpha, it's a new letter. Square root 3 over 2. Cosine of alpha. Tangent of alpha. Questions? Okay, listen. There is the unit circle game in Canvas. It's linked to you in Canvas. Guys, you need to practice that until you cannot miss, because tomorrow you're quizzing.
Oh no.
Unit circle game in Canvas. Get good at it.
I think I'm good.